Welcome to this next tutorial, and today we're going to be looking at the PCA9685 servo driver board again, except today instead of using one of these boards we're going to be using three, and we're going to be controlling LEDs and servos at the same time. Now, for those who are following from a model railway point of view, the reason for this is so that we can do track movements and signalling all off the same board. But for those of you who aren't doing model railways, if you want to move multiple servos and multiple LEDs, this hopefully will help you in that goal. So let's have a quick look at the project we're going to be building. So this is today's project. It's a bit cramped on the board. Over here we have the one servo that is connected to this servo board. As you can see, it's moving slowly backwards and forwards, and in time with it, these LEDs on the right, these four, they are changing their brightness in conjunction with the position of this servo. This other servo is connected to another board over here. As you can see, that's flicking backwards and forwards on its own quite nicely, and the LEDs here are going on and off in time with that. So that's the project. What we're going to be learning is how to use two different servo boards and an LED all at the same time. So that's the project. Sorry about the dodgy servo bottom left that was moving slowly. It's been ripped out of another project and I didn't want to disconnect the bracket from it. Anyway, let's get on with the project. So as we look at our board, let's look top right, and the first thing I want you to notice are these solder pads. Now the board, when it has none of these soldered across, has an address of hex value of 40. If you solder across these different pads, you will change the addresses. Now, I don't care which ones you solder across, but if you're using three boards in the project, maybe solder across A5 and A2. It doesn't matter which ones, but just make sure that the arrangement of pads that are soldered across is different for each board, and obviously you can leave one board unsoldered because that will just use the default address. Now, once you've soldered those pads across, let's move down. We'll do the warning at this point. When you build this circuit, do not try and connect all the boards to the Uno and power everything from the Uno. If we look at the circuit, you will see that at the top I've put to have a separate 5-volt power supply. This is important because if you start drawing lots of power from your Uno, you're going to start to smell smoke coming out of it, and that's going to be the end of it. So you have a separate 5-volt power supply. So the VCC pin is getting 5 volts from the Uno. All that is doing is powering the circuitry of the board, if you like, the control mechanism of the board. The separate 5-volt power supply is powering what is actually attached to these pins, and the same over here. Now, in the diagrams that I've got here, I've got one servo on each board. The way the code's written, you can plug into any port. In fact, you can plug all 16 servos in if you wish on both boards and watch 32 servos move at the same time. Believe me, you will need a separate 5-volt power supply for that because your Uno will have a bad day. The same on the LED board. You notice I've only put 4 in. In fact, again, all 16 ports are in use if you want to use them. But if you've only got a couple of LEDs, just put one in the first set of 8 and one in the second set of 8 to get the effects that you want. The reason I've done this with just the one item is, let's be honest, most of us haven't got 32 servos knocking around, and we're just learning how to do something. So there's no need to connect everything up, but just do it, one in each, just to get an idea of what's going on. Right, now let's look at the wiring. There are two ways of connecting up these boards, and I've tried to show both in this diagram. You can daisy chain the boards, so if you like, you know, ground the VCC live, SDA and SDL going in, and then coming out the other end of the board connecting to the next board, so you can daisy chain them that way. Or as this board is, it's connected to the same SCL and SDA pins. I'll be honest, in my projects I tend to like all of my boards connected to the pins rather than daisy chaining them. For me, daisy chaining them, it just means something somewhere I'm going to have a bad connection. So what I tend to do is, I'll be honest, I don't tend to use the Uno for production stuff. I'll use the ESP32, and I will put that onto some Vero board, onto some headers that I solder in, and then I mount some plugs on the board so that I can plug the individual PCA9685 boards in. Now, once we've got it all wired up, testing time. Now, the bane of all Arduino projects is bad wiring, let's be honest. So if you have got this wired up correctly into your breadboard and you have soldered across the pads so that they all have different addresses, what I want you to then do is do a connection test where we'll go to the Arduino IDE. I want you to run the I2C scanner. Now this is in your examples. Go down to examples, scroll down until you get to wire. Unfortunately, I've got so much stuff on this. There we are, wire, and there you are, I2C scanner, and you will load this sketch. Load up the sketch onto your board and you should get something like this. So on mine, I've got this first board which I haven't soldered any of the pads, so it's given me address 40. This one's got a pad soldered and I get address 41. This one's got an address soldered and I get 46. Sometimes you will get this odd value appear. Don't worry about it, just ignore it. You haven't got to panic. But providing you've got your 3 board addresses, everything is okay and your boards are connected correctly. Now, one other thing that is worth doing is unplugging the boards one at a time and making a note of which board has which number, because you're going to need that when we start the sketch. Now, the next part, if you haven't done it already, you know, if you've not done the previous examples, and I would advise you to go back and do the previous examples that I've done. Again, you just go to the Digital Town website. There'll be links at the bottom of the page related to this video to some of the previous sketches. Make sure you've got the Adafruit PWM servo driver library installed in your Arduino IDE, because without that you're going to be in trouble. Right, let's get on with the first proper sketch. So here we are in the sketch, and as we saw in the I2C scanner, those addresses, I actually made a note of them and put them into my sketch header. That way I'm not going to lose them. Now we need to install the wire library and the Adafruit PWM servo driver, and then we need to set up the boards. Now I am going to use board address 40 for servos, board address 41 for servos, board address 46 for LEDs. So let's come down to the code here, and this is where we create our different objects. Don't panic about it, just follow the example. So I've got servo board 0 is 40, servo board 1 is 41, and my LED board is 46. You don't need to worry about what is going on here, but that is the way that, if you like, we start to set the system up so that it can basically contact the different boards. Right, there are some values here that you will have seen in a previous tutorial. These are a minimum and maximum value that are sent to the servo. Again, you don't need to understand that. Also, there is a thing here called the servo frequency. Servos like to run at 50 kilohertz. I've then got a line here for the LED frequency. LEDs run at a completely different frequency, so the higher the frequency, the better. 1600 is absolutely perfect. So if we go down to the setup, obviously we're going to start with the serial. Just to help you, I have left some of my serial print statements in. It wasn't an accident, and that is deliberate. That's helps you find now and again where you are. Obviously in a production job you wouldn't, you'd take them out. Anyway, let's start the servo board. So servo board 0, we're going to set its oscillator frequency, and then we're going to set the servo frequency. We're then going to do that again for servo board 1. So we've got the object, we've now, if you like, we've pressed the go button on the engine. On each one we're setting some speeds that it's going to be driving at, and now when we go down to the LED board, all we have to put in here is start the board and set the frequency. It doesn't have the oscillator, set oscillator frequency, doesn't need it. And then there is a little delay of was it 0.1 of a second, something like that, 10,000th of a second, like 0.0 or whatever. Anyway, that's just to let everything settle down. That is the only delay that this code needs. We do not like delay in our code. The reason we don't like delay is that whenever you put delay in your code, basically the Arduino stops in the state that it's in and you can't read any inputs from anywhere else. Okay, going back up, there's a few variables. There is an unsigned long called current millis. Because this will be using a state machine type code for timing instead of delay, for the reasons I've said, because this is going towards a model railway project, if you start putting delay in your code and you want to use buttons or sensors, it won't work. So you've got to get used to this method. So current millis, and all that's used for is at the start of the main loop, we set to the value of current millis to the current milliseconds since the board started. So that's starting our, that if you like, is keeping track of time for us. Now going back to our variables, I'm breaking this into two sections. I had the one servo that was moving rapidly. So for that I have a variable for its direction, its position, and a timer for when it should move. And then for the slow sweep, we have a target that it's aiming towards, its current position, and again a timer. So those are the only variables that we need in this sketch. Now again, I'm using timers to control when things happen, but I've done an example where we're moving servos with buttons. I'm just using timers for this example, but you can use this code, combine it with the button code, and you can move your servos at the press of a button. Right, let's start to look at the code. So this bit here is just to do with the timing. So what it's saying is, if the current millis, so the current time in milliseconds, minus the value of the rapid move timer is greater or equal to 3000, that's 3 seconds, then we're going to make a move. Now if we make a move, we reset the rapid move timer to the current time in milliseconds, so that in 3 seconds it will do it again. Now what I've done is I've put a serial print in there so that you can see on the serial monitor that the rapid move timer is doing something. Now obviously we've got two directions, clockwise, anti-clockwise. If the value of the rapid move direction is greater than 0, then we're going to set the value to 0, because if you like, we've moved one direction, we're going to move the other direction. And if we're going to set the move direction to 0, we're also going to set the move position to 0. This is the angle in degrees that we're going to set the servo to. Now, once we've done that, we've got an else statement. We've then got, I'm going to skip the LEDs and we'll just continue with the servos. The opposite, of course, is if it's 0, we'll set it to 1, and we're going to set the servo angle to 179. And again, I've put a note in there so you'll see it goes to 179. Now, at the same time within this function, we're also going to be altering those LEDs. So if we're going to move the position to 0, we're going to send this instruction. Q is reset at the beginning of the loop, and Q is just because I'm a lazy programmer and it's top left on my keyboard. It's just something that's holding a value. We've got a for loop for Q equals 0. Q is smaller than 8 because we start at 0. We don't, although it's a 16 port board on the PCA9685, the first port is not 1, it's 0. Something to get used to in programming. We tend to start with 0. So 0 to a value of less than 8 is going to be 8 ports, 0 to 7. And what we're going to do is set the value here to 4096. Now, the values that can go in here for the light to illuminate is 0 to 4095. If you set it to 4096, the LED turns off completely. On the opposite side, if we're moving it to 179, because again, we're moving the servo 180 degrees, but 0 is the first value, so 179 is the maximum value. This time I'm going to set it to maximum brightness, which is 4095. And then what we're going to do, now that we have a position that we want to move to, we're going to move through all 16 servos. Again, we're going to use Q. So this is a function that I've created, and we're going to say 0 Q and a position. Now 0 means we're going to move board 0. Remember, we've got 2 boards. The Q is the servo port, so we're working through all 16 ports, and rapid move position is the position here, or further up when it's 0 up there. That is the angle that we're sending the servo to, and what it's doing is it's calling this function set servo position. Now, for those who have done the previous tutorial on the servos, this is the old tutorial, again there'll be a link to this. There was a function that I created to make it easier to select the servo, and it takes the servo number and the angle that I want to set it to. You just pass it those 2 values and that's it. That's all you needed to do. The difference now is that we have multiple servo boards, so we're not just sending the servo number that we want to move and its position, we also need to know which board it is. So in this version, this function has been changed. So let's scroll up now to the set servo function. Again, I've tried to make it as unscary as possible. So we've got this function here. We're passing a servo board value, the servo number, and the position. That's the angle. You don't need to worry about these bits of code here because it's doing stuff that you just don't need to know. What it does though, the big addition in this is, in the previous version it would just send the value to the servo board. This time, if you remember when we set up the code I've got servo board 0 and servo board 1. Boring names, but that's all I could think of. If we now go to our function, if I pass a value of 0, I'm going to move servo board 0. If this is a switch statement, if I send a value of 1, it's going to move servo board 1. Now unfortunately I haven't found a way to be able to pass this bit here, servo board 0. This is the only way I've found to do it. So if I wanted to add more servo boards, I've commented out the code here, but you know, if I'd got another board, I'd call it servo board 2, and again I would just add another case statement in. So again, just copy and paste this, increasing the value and putting your servo board numbers in. I've also put a default here that if you've sent an invalid value, so if I sent a servo board number of 23, it's going to come up in here, you know, invalid board. So at least I'll know why I've made a mistake. So all you need to do is, as you add boards, add in those extra lines, and the rest of it in your code to move the servo, you're just sending the board number. Where are we? He says looking rapidly. There we are. So I'm sending the board, the servo number, and the position I want it. And you know, you could have various values being put in here, moving different servos on the same board to different positions. So that is the end of, if you like, how you saw the servos in the video moving rapidly with the LEDs switching on and off. But of course sometimes you don't want to move things rapidly, you would like to move things slowly. So I've put a comment line in that where the end of the rapid movement ends in the code and where the slow movement starts. Now if you remember the rapid movement right at the beginning, we had a value of 3000, so it was moving every 3 seconds. One of the things you'll notice in the slow movement is I'm moving it every 0.05 seconds. It's going to move 1 degree. So because this number is smaller, this value is going to come around much quicker. And what it's saying in the code, if you remember the variables that we had at the top, we have a target. So that's the value that the servo is aiming to get to, and we have its current position. So if we go down again to our code, what it's saying is if the target position is not equal to the current position, in other words, it hasn't got to its target yet, then if the target is a higher value than the current position, then increment the current position value, and if it's obviously the opposite, if it's a smaller value, make it smaller. And then what we're going to do is we're going to tell those servos to all move to the new position. So each one of those servos is either moved clockwise or anti-clockwise 1 degree. Now of course in our if statement we said if they're not equal. Now of course there is going to get a point where they're going to be equal. So when those values are equal, this is where this part of the, so we've got the if statement, so we've now got an else there. So if they're not equal, do that, else do this because they're equal. So if the slow sweep target is greater than 0, set the target to 0, because I'll be honest, if it's greater than 0, I know it's going to be 179. So it's moved to one extreme, let's set the target at the other extreme. And of course if it's not greater than 0, I know it's going to be 0, so let's set it to 179 so it sweeps in the opposite direction. That will then create these slow movement as you saw on the video of the ugly looking contraption bottom left. Now the LED brightness, just to there's a bit of an equation in here, so I've got a value for the LED brightness. and it's 4096 because it's 0 to 4095, so 4096 steps. I'm going to divide it by 180 because there's 180 degrees. Then I'm going to multiply it by the current slow sweep position, and then I'm going to subtract 1 because otherwise it'll max out above, it'll go to 4096, which will turn it off when it gets to full brightness. You don't need to worry about this calculation. I just put it in here just to try and alter the brightness. It doesn't work particularly well because the brightness of the LEDs doesn't tend to change in a really linear way. But then all it's doing is going through the LED board, and this time it's doing pins 8 to 15, and it's setting the LED brightness. So that is how all the code works. I hope it's been useful to you, and just take a look at the video again, think through the code, and hopefully that will help you in how to use the multiple versions of this board going forwards. So again, hope that's been useful to you. Check out the Digital Town website because it'll have all the code, circuit diagrams and all the rest of it. And if you find this useful, please click the like and subscribe because there's some more videos coming up soon. Bye for now.